Hello, good people, and welcome to the class once again. In this lesson, we are told the network analysis, and we have been given a question, and the question states as follows: We have been given activities, activity A up to activity H. We are also given the preceding activity. The preceding activity is the activity that must be finished first before we come to the activities given. And then we also have been given the duration. The duration is given in weeks, right? For example, the activity A takes 3 weeks, activity B takes 4 weeks, and so on and so forth until we get activity H having taken 10 weeks. You can see from the information given here, we are also required to draw the network diagram. Draw the network diagram, number 2, to find the critical path, and number 3, to find the project duration. Now, in solution to this, we are seeing that A and B have no preceding activity. There's no activity that must be finished before we start activity A and B. And therefore, we come to the start node. Remember, when we are solving, we have to remember that the start node, the activity that starts must start at the start node, and the last activity ends at the finish node at the end of the diagram. Now, because this is our start node, we have to put the 0 and 0, meaning earliest start time and earliest finish time is 0 because there is no activity carried out at this point. From this 0 start point, we have to proceed to activity A. Now, this is activity A, and we are given the duration as 3 weeks. So we insert 3 weeks along that line. Remember, the activity is shown as an arrow. And then once again, we also have activity B because A and B have no preceding activities. So A and B have come from the start point. They are the beginning activities, and the duration given is 4 weeks. As we continue, we can see again activity A precedes C. So from activity A, after finishing activity A, we go to C. And again, from activity A, we also go to D. So we can see from A, we can proceed to activity C. See there. And again, it's an arrow, and the duration is 7 weeks. And then once again, we also come from A and move to activity D. D is here, D is shown as an arrow, and the duration is 2 weeks. Once again, we go up and look at activity A and F. Activity A has produced C and D. So from A, we have moved to C and D. So from A, we have activity AC, that's 7 weeks, and AD activity taking 2 weeks. Further, we look at activity B preceding activity E. So we draw an arrow from B to E, all right? From B to E. So we look at the diagram and we have our B here. So we draw B moving to E. And the duration given for E is 5 days. So you insert the duration, and also remember to have the activities indicated or shown by an arrow. The next one is activity F. Activity F is preceded by D and E. When activity F is said to be preceded, it means that we shall have arrows from D and from E, both moving to activity F. So you can look at our diagram. We have activity E and D. So we shall move from D and then move from E. We shall meet at a point called F. That is our activity F. And the duration given for F is 8 weeks. And remember to put the arrows showing that we are doing an activity. The next one is activity G. Activity G is preceded by F and E. So once again, from F and E, we shall move to G. So we draw two arrows, one from F, the other one from E, and they shall proceed to G. So we have our activity F here and E, and both are meeting at G, and the duration given is 12 weeks. Could be weeks or days, but we have been given this to be weeks. Then lastly, we have the diagram or the question saying activity FH is preceded by activity C and G. Therefore, we shall draw an arrow from C, another from G, and they shall meet at a point H. So let's go to the diagram. We have C and G, and so we shall draw an arrow and another arrow. Both will meet at H. These are arrows. The activities are shown as arrows, and the duration given for the last activity is 10 weeks. Having done that, now we start the forward pass. The forward pass is moving from the start point or start node up to the finish node. How do we do that? We shall take the smallest number, that's the earliest start time. We shall add the activity duration and write the next earliest start duration or start time in the next activities box. So for example, for the earliest start time of BE, we shall have 0 plus 4, then we shall insert 4 on the earliest start. Once again, we shall move from 4, and then we add 4 plus the activity duration. We shall get 4 plus 5 will be 9. So we insert 9, and then we also take our time. On the other side, we have 0 plus 3, we get 3. Again, we have 3 plus 7, we get 10. So you insert 10 in that diagram. And then we come to 3 plus 2. 3 plus 2, we have that gives us 5. And then once again, 5 plus 8 gives us 13. Right? And we see activity F has two arrows coming to it. And therefore, we shall look at 5 plus 8 getting 13, or we could also say 9 plus 8 getting 17. We have two numbers here. It could be either 13 or 17. When we are going for the forward pass, when we are moving from start to the finish, we pick the number that is larger when two activities are coinciding. When two activities are coming together or coinciding, we pick the bigger number. Okay, so we have 9 plus 7, 17, or 5 plus 8, 13. So we pick 17 because 17 is bigger than 13. Then we have 17 plus 12. That gives me 29. Or in the same way, we could also have 9 plus 12 giving me 21. So I will pick 17 plus 12, then I will write 29. Reason being 9 is bigger than 21. Once again, we consider 10 plus 10 giving me 20, or 29 plus 10 giving me 39. So I will pick 39 because that 9 is bigger than 20. That is the forward pass. Having finished the forward pass, we also pick the last and the earliest start and the earliest finish or the latest finish, and we copy the 39. We just insert another 39 on the other side of the box. Then we start the backward pass. That was the forward pass. According to the movement of the arrows, direction of arrows from left to right, called forward pass. Now we begin the backward pass. This is done by subtracting the latest finish minus the activity duration. For example, in this place, we shall have that 9 minus 10, and that will be 29. Once again, we have 29 minus 12. We can have 17, or we could go to 9 minus 12. We get 17 here. We get 17. And then you also consider 17 minus 8. We're getting 9, or 9 minus 12, we get 17. When we are doing the backward pass from end to start, we write the smallest number in every place that we are coinciding. Activity F and G come together at G, and therefore we shall pick the smaller number between 9 and 17. So we shall write 9. Okay, now we move to the other side. We have that 9 minus 10, we are getting 29, and then we have 29 minus 7, 29 minus 7. So we also consider this area, this line, so that we write the smaller number among these two. Let's go. 29 minus 12 is 17. 17 minus 8 is 9. Then 9 minus 2 is 7. We can either write 9 minus 2 being 7 here, or 29 minus 7 being 22. So we shall pick the smaller number among the two, and this will be 9 minus 2 being 7. And then 9 minus 5 is 4. 9 minus 5 is 4. And we said when we are coming back in the backward pass, we shall be picking the smaller number. Again, we are having a junction here. We have 7 minus 3 giving us 4, or 4 minus 4 giving us 0. And because we have to pick the smaller number, it's either 4 or 0, and we pick 0 because 0 is smaller than 4. Roman 1 has been answered. Draw the network diagram. Draw the network diagram. That has been done. And then you also look at find the critical path. Now, the critical path is a path along which there is no float. What is float? Float is the time that can be saved without adding the duration of the whole project, or the duration by which an activity can be delayed without affecting the activity duration up to the end. That is the project duration. Now, the critical path will be seen by having the same numbers in every activity end. The end or finish will have the same number. So we have that 9, and we have 29. So this is the critical path, and we shall indicate that by having two parallel lines across that activity. You also consider 29 and 17, and this is also another critical path line, and we should indicate it using the two straight lines across that activity. Once again, we have 29 and 99, and so this becomes another activity that is along the critical path. Same way, activity F is another activity that is along the critical path. We consider the 39 and also look at the 27 and 10. That is not a critical activity. We look at 17 and 9, 5. They're not equal here, so it can be a critical activity. We continue down here, 9 and 4. This again becomes a critical activity. Then you also look at 4 and 0, that becoming a critical activity again. So when we are asked to get the critical path, we write the critical path as follows. We have activity B along this critical path having been defined as the longest path. So we can have activity B, E, G, and H. But then, if we add the F along the same way, if we go from B, E, F, G, and H, that becomes the longer activity, the longer path, compared to B, E, G, and H. So we shall write B, E, then we move to F, then from F we go to G, and then lastly we go to H. That is a critical path. The longest activity lines or path in the whole diagram. The last question is find the project duration. The project duration is given by the longest path from 10, 12, 8, 5, and 4. And that gives us the duration of the project as that 9. When we are stopping the project or finish the project at the activity H. And the finished activity or finished duration will be that 9. So we can say the project duration is given as 39 weeks. 39 weeks, and that is how to draw the network diagram. And thank you for watching, and may God bless you.